Lesson 6-2, Patterns and Expressions. We can use patterns to write algebraic expressions. So we'll do an example here in a moment where we are using a pattern to find an equation that represents the entire relationship. We're also going to be replacing variables with numerical values to solve. So you might see an example like this, where it says t times 4 and t equals 3. So we're going to do a couple of those examples here in a few moments. Let's take a look at an example of using patterns to show relationship. So in your book on page 148, there's an example at the top that says, Shauna wanted to buy tickets to the concert for herself and some friends. What is the total cost of all the tickets? Let T represent the number of tickets. So here is the table that Shauna made so that she could find out how much it cost. So for 2 tickets, it cost $8. So we multiplied by 4. For 3 tickets, it was $12. Again, we multiplied by 4. For 4 tickets, it was 16. We multiplied by 4. For 5 tickets, it was 20. We multiplied by 4. So if the value was t, you would multiply the t times 4. So no matter how many tickets you bought, you could multiply that number by 4 to figure out how much you were paying. So this is a pattern that we see, and then we use the pattern to solve for what they're asking. Pause the video to try the example below. Make sure that you are solving for Fred's plant and that you can replace the expressions for the sentence. It says, after 5 weeks, Sarah's plant was 8 inches tall, and Fred's plant was 3 inches taller. So 3 inches taller. Write an algebraic expression to represent Fred's plant, which we did. And then it says evaluate the expression if Sarah's plant is 3 inches or if Sarah's plant is 5 inches. So we can make a table. We can say if Sarah's plant is 3 and 5, then Fred's plant has to be, because this is H, it has to be 3 plus 3, so Fred's must be 6. The 5 must be plus 3, so Fred's must be 8. So you can use an expression to continue figuring out how tall Fred's plant actually is. Now we're going to take a look at replacing the variable with numerical values. So to do this, you would be given an expression 35 over n, but they would have to tell you what n is in order for you to be able to solve. So they've said that n is 5, so this means that this is 35 divided by 5, so n equals 7. The next one is 3z. They've said that z is 4, so 3. Remember, anytime that a number is sitting next to a variable, it means to multiply by that numerical value. So 3 times 4, which would be 12. So z equals 12. Pause the video to complete this lesson review. Make sure you show me this lesson review for verification of watching this video.